Imagine, if you will, a world where everything is made up of tiny vibrating strings. Picture a universe where everything that exists, from the smallest subatomic particle to the largest galaxy, is composed of these minuscule strands of energy. Sounds intriguing, doesn't it? Let's take a step back. Traditionally, our understanding of the microscopic world has been based on the concept of point particles. Particles like electrons and quarks, the building blocks of atoms, have been considered as zero-dimensional points with no size, just a specific location in space. But string theory challenges this notion. It proposes a radical and elegant idea. What if these particles aren't points at all? What if, instead, they are one-dimensional objects, tiny loops or strings of energy? These aren't ordinary strings, mind you, but incredibly small ones, so minuscule that if an atom were the size of our solar system, a string would be as small as a tree on Earth. And these strings, they aren't just static, they're dynamic, vibrating at different frequencies. Now you might be wondering, why does that matter? Well, it's these different vibrations that give rise to the diverse particles we observe. Just as different notes are produced by different vibrations of a guitar string, different particles are the result of different vibrations of these fundamental strings of the universe. So, electrons, quarks, photons, gluons, all these particles, they're not different because they are fundamentally different kinds of entities. They're different because they are strings vibrating at different frequencies. An electron is a string vibrating one way, a quark is a string vibrating another way. This idea, this grand unifying concept, is what makes string theory so revolutionary. It suggests that at the most fundamental level, everything in the universe is made of the same stuff, these tiny vibrating strings of energy. So in essence, the universe is like a grand symphony, with each string playing its part. And just as a symphony creates beautiful music with the combined sounds of many instruments, the universe weaves the rich tapestry of reality with the diverse vibrations of these fundamental strings. Now here's where things get really interesting. String theory suggests that there are more dimensions than the ones we experience. We're all too familiar with the 3 dimensions of space: up and down, left and right, forward and backward, and the 1 dimension of time that relentlessly ticks away. Together, they form the reality we experience daily. But what if I told you there's more to the universe than meets the eye? Enter string theory, an audacious idea that challenges our understanding of the universe. It proposes that there might be up to 11 dimensions, not just the 4 we're accustomed to. But where are these extra dimensions? Why can't we see or feel them? Well, these extra dimensions are thought to be compact and hidden from our perception. Let's use an analogy to simplify this concept. Imagine a tightrope walker, high above the ground. To her, the rope exists in 1 dimension. She can move forward and backward. But what about the tiny fibers that make up the rope? They wind around each other, creating extra dimensions that the tightrope walker can't perceive. In a similar way, string theory suggests that our universe may be made up of tiny vibrating strings existing in these compact hidden dimensions. These dimensions, though invisible to us, could be influencing the universe in ways we can't detect. These hidden dimensions, according to string theory, might just be under our noses, influencing the world in ways we can't detect. String theory is beautiful, but it's not without its challenges. Indeed, string theory has faced its fair share of criticism. Its complexity, for one, is truly mind-bending. The mathematics involved are intricate, requiring a level of mental gymnastics only a few can muster. Moreover, there's the issue of empirical evidence. As it stands, string theory remains largely theoretical. Its predictions are so far beyond our current technological capabilities that testing them is, at present, a pipe dream. And then, of course, there's the competition. String theory isn't the only game in town. There are other theories, equally tantalizing, that seek to reconcile the strange world of quantum mechanics with the grandeur of general relativity. But let's not forget the promise of string theory. It holds an allure that's hard to resist. If proven, it could offer a unified theory of everything, a framework that can explain both the vast cosmos and the unpredictable realm of the quantum. Imagine being able to understand why galaxies spin, why stars burn, and why particles behave the way they do, all under the same theoretical umbrella. While string theory remains unproven, its promise is undeniable. It's a theory that could change our understanding of the universe, and we're just at the beginning of this exciting journey. So stay curious, keep questioning, and let's explore this remarkable universe together.